Hello and welcome to BlastOne International's tutorial on this particular piece of equipment, which is called an AirPrep. An AirPrep is basically an aftercooler. What an aftercooler does is cools the air as it comes from the compressor into this particular receiver or pressure vessel. So an AirPrep is designed to have an inlet or an accumulation bowl on it. What the accumulation bowl does is it receives the primary air. Any air that's got any moisture in it is vented through this particular valve here, and as you can see, the water dripping out of it. So ultimately, when you start using these machines, the first thing that you do is you leave one of these valves, this valve here, cracked open slightly. Not excessively, because if you open it all the way up, of course, you're losing too much air that the compressor's making unnecessarily. So you've got an accumulator here, the air comes in. So how do we get the air into this thing? Well, primarily there is what we call a bull hose. So the bull hose comes from the compressor. So the best way to do this and to keep yourself safe is to hook this on to the unit first before you hook it onto the compressor. So there's no chance of anybody actuating air through this particular hose, because as you can see, it's quite substantial. Rule of thumb is, with these particular hoses, if you can depress it with your foot or crimp it with your hands, there's no air in it. So if the end's open, of course it can't have any accumulated air in it at all. What I prefer to see on these particular hoses is a double bolt clamp, so 2 bolts. The keepers are on the top. It's got a shoulder on the ferrule, and that pushes down inside. The hose tail goes right inside this particular hose. We also use silicon or Sikaflex to help assist and hold that particular hose in that hose tail. Also, you'll notice in the front of this particular mince-up coupling, so this is called a 2-inch mince-up coupling. In this here is a seal or a gasket. So that gasket on these particular units has got a steel ring in it. So it's somewhat difficult to get it out, but if it's compromised, damaged, not concentric, it needs to come out and be replaced. So what you'll find you'll need to do is you'll need to pry this one out with either a screwdriver or a pair of pliers. So you'll actually undermine the wall or the integral wall of this particular O-ring to remove it. The one thing I would suggest is you use graphite dust when you put the new one in. So you smother the new one with graphite dust because it's a dry lubricant, it's not grease, and won't have garnet or any other contaminants adhere to the lubricant. So by putting graphite dust in, you enable the gasket itself to slip into this particular housing where the recess is. So there's a recess behind this gasket that enables this to push the back of the seal open, balloon into the recess, and doesn't come out easily. It's important you don't leave these hoses open in a dusty environment or dirty environment, primarily because it can accumulate dust and dirt inside this hose, and when you connect it to this particular unit, you're just contaminating the aftercooler fins that are on the top of this unit that we'll discuss very shortly. So it's important that you check these particular fittings, make sure the bolts are done up tight, make sure that the gasket is in good repair, and make sure also that the mince-up clips are square and haven't been damaged or run over. So ultimately, if someone run over this with a truck, forklift, whatever, it's compromised, has to be removed and replaced. Important thing to remember, when you cut these hoses, always cut them square so that the square face edge of the hose marries all the way back to that leading edge on this particular fitting. By doing it that way, you know that it's square and the clamp's got a good chance of getting all the premise of the hose itself clamped and held behind the ferrule that's on the back of this hose tail. So it actually pinches this hose onto a leading edge that is on the hose tail at the end of the hose tail itself. So that 1, 2, and the silicon is 3 types of retention to hold that hose into that fitting. Why am I pedantic about these? Look at the size of the hose and the amount of air that it can carry. Imagine the pressure that's behind this. So if this is compromised in any way, shape or form, it deems it unsafe. And with that comes the fact that you could get hurt. So why get hurt at work? It's crazy. You need to make sure that you have all the appropriate safety equipment. So what also goes with this particular fitting is this item here is called a whip check. So the whip check is spring loaded with the two retaining eyes there, so you slide it back and fit it over the fitting as such. So that then enables me to put it on there. I can leave it on here like so until I've fitted it to this particular unit. So when I get it in place, then I can slide it up. Remember, hose whips have to be taut. You can't have it loose with slack, because then it won't do its job. If this came undone and this is slack, it gives it the opportunity to come back and hit you while it's whipping with no restraint. So the restraint here is the hose whip. So this particular fitting's got a gasket, so is the marrying fitting for the mince-up coupling. It has a gasket in it as well. You must check that that gasket's in good repair and hasn't been compromised by damage or wear. With these mince-up couplings, you'll have two holes either side, 1, 2. Those two holes marry with the set that this couples to. So that's why it's called a coupling. It couplings into its partner. I always use 2 pins, 2 safety pins with these particular fittings, primarily because it's twisted to make it house in the seat. And if you don't put 2 pins in, what can happen is, with a twist on the hose like so, and you put air on there, watch what happens to this fitting when I let it go. See, it's just made a quarter of a turn before it's located in the little dog. So even the dogs on the fitting itself aren't enough to hold that in place. So if I move that, see what happens? It just falls off. So basically what you'll do is put it on like so, and if there's too much recoil required in the hose, go back, appropriate the hose, take the torque off the fitting. You don't want any torque on the fitting, and then put the pin in. Now you can put the pin in either way. You can put it from the bottom up or the top down. The best way to do it is from the top down, because if I put this pin in place with it up like that, then what's happened is it leaves a sharp edge exposed, so that if I have to do anything to the machine, I can actually cut myself open. So the best way to do it is with these pins, is to point the pin down. Now the other thing too you can do is, you're not compromising the pin, but if you're concerned that that might be too sharp or create a problem, there's absolutely nothing wrong with this piece of spring. With another pair of pliers, just bend it round slightly so that it doesn't remain open with the edge pointing out. So I've got no problem with that at all, as long as the pin still maintains that shape and this outer edge marries with the inner edge. So always 2 pins in what we call a bull hose. So that's a bull hose, that's a primary hose that feeds from the compressor, and it always has 2 pins. So they do have the capacity to twist. So you'll find that too, sometimes the pin doesn't line up with the hole, so just turn the fitting around until you get the location of the hole and the pin slides through. So that's one bull hose. Now look at this particular unit, it's got 2 inlets. And always on this unit it'll say inlet and outlet. So the inlet is the primary side, the outlet is the exhaust side. So the primary side is the air in. So all the air that we're getting here is going in and through this particular cooler. Now on this side, say for example, I had 2 blasters working and I needed more air, so one 400 CFM compressor wasn't enough for one blast pot. This enables me to put another 400 CFM compressor on this bull hose attachment and run 2 400 CFM compressors into this particular unit. I still need this valve cracked slightly, and then when I've appropriated the other hose, I'll open this valve and I can have 2 lots of air coming into this. This particular unit is a 750 CFM AirPrep. You can get a 250, you can get a 400, you get a 750, you get a 900, and you get a 1200. So in that sizing of those particular units, it does 2 things. One is, it appropriates the amount of air that's required to operate the piece of equipment that's attached on the other end of it. But you have to bear in mind that with that segmentation of sizing comes the aspect of the facilitation of air on the exhaust side of it. So for example, you wouldn't use this 400 CFM pot, or let's say for example, to put it in layman's terms, A number 7 nozzle requires a 312 CFM of air. If you used a 250 CFM AirPrep, you're right on the precipice of how much air that aftercooler can cope with the volumetric air that it consumes to facilitate your nozzle output. So in this case, we can run a 750, two 6.5 cubic foot blast pots quite adequately and still maintain dry air, because this particular unit has got the capacity to adequately condition the air as I drag it off. So what's the big plus with this particular unit? Why would I use an aftercooler? With any abrasive application, moisture is your biggest enemy. Why? Because it can consolidate the grit. It can cause me problems with the automatic aspects of a blast pot and the fundamentals of the valving itself to appropriate the grit out the other side. The beauty of this also is that I can run all my airless equipment off this. It's all dry air, so I'm not making my airless unit susceptible to moisture. So the big plus here is we've got a fan arrangement underneath to draw the air through the fins, and the fins just look like the radiator in your car. That's basically all they are, only you've got air running through them. So the fins give the air pulled through time to cool those particular capillaries and cool them down, pull the air through, and then the air that comes out the other side is cooled right off. Here we have a regulator and an oiler. So what's this for? Well, underneath, as I mentioned, there's a fan. So the fan is pulling the air through the fins on the radiator up top, through the fins, cooling them. So it's important that this is running all the time. So you can see up here, do not exceed 60 psi. So the 60 psi relates to the air motor that's underneath. Why do they put 60 psi as a maximum? Because they've worked out that 60 psi of air running over that air motor is the maximum amount those bearings and the impeller in that motor will take to give you longevity, and also to maximise the amount of air that the fan's pulling through the fins on the cooler on the top. So you've got an oiler here. The oiler keeps the lubrication up to the fan that's underneath, or the fan motor, and the two bearings, one top, one bottom. And the oiler here has a sight glass on top. The sight glass enables me to appropriate how much detergent oil or lubrication I put through the automatic oiler. So what happens is the air comes through and it'll drag from a Venturi system the oil. So don't forget, when you appropriate your hose on here, to slide your whip check up to make sure it does the job appropriately. So close it home on the fitting, make sure it's tight, slide the whip check down so that it's taut. So if this hose comes off, this restraint will hold that hose in a position to enable you time to diminish the air that's pushing through this particular hose. So as far as lubrication is concerned for this particular unit, we have an oiler and a regulator, and that is for the air motor that's underneath. The air motor that's underneath there pulls the air with the utilisation of fan blades through the fins on the radiator to get this air that's going in cool by the time it comes out the other side. So to appropriate the pull of air, we utilise a fan underneath. So the fan on this particular unit is quite sizable to have the amount of air adequate to cool the fins on the radiator. So this particular regulator, it says here in big letters, do not exceed 60 psi on air motor. So this regulator appropriates the air or the rotational spin of that particular pneumatic motor underneath. The pneumatic motor underneath has two bearings in it, top and bottom, and two seals, top and bottom. So they need lubrication. This particular thing is an oiler. It's called an automatic oiler. The automatic oiler, with the air from this particular receiver, comes through the regulator. The regulator appropriates the amount of air we put through there. So the air motor needs 60 psi, so you'll screw this regulator knob down until you reach the 60 psi. Don't exceed it because the bearings can't cope with the amount of speed you're putting on them. And then the air travels through here and through a Venturi system. there's a little sight glass there. The Venturi system takes the oil with it down to the air motor. So the oiler has a sight glass. In that sight glass, you'll see a little drip. And it says here, lubricate with 1 drop per minute of SAE 10 for every 50 to 75 centimetres. What is that? Lubricate 1 drop per minute. So so this little sight glass here tells me or shows me a drip. So for every drip, it's appropriating or dispensing some detergent oil into this air line. So that's lubricating the air motor that's spinning with 60 psi of air over it. So without oil, the bearings of course will run dry. So what happens with this oil that we're shoving into this air motor? Where does it go? Remember, anything that's pneumatic, where air goes in, it's got to come out. Well, on this particular air motor itself, there's a hose here that runs down to the bottom beside the receiver that has a small muffler on it, and that oil, excessive oil, runs down and is exhausted out the bottom. So the air motor itself has to exhaust somewhere. So the muffler on the bottom keeps it quiet so it doesn't exceed noise levels. The other aspect of it, of course, is that it needs to vent somewhere, so it vents at the bottom. If there's excessive oil dripping from the bottom of that particular vent hose, you know that there's something wrong here as far as the dispensation of oil in relation to the amount that they request here. So when they say SAE 10 detergent oil, when it's a 10, you know that it's a thin viscosity oil. So what could I use in there? Just say, for example, I'm on site and I think, uh-oh, we've run out of SAE 10 oil. What do I do? To be quite honest with you, any low viscosity oil is more than adequate to lubricate that air motor. So I could use Tellus 10, I can use automatic transmission fluid, ATF, which is red. That's fine because it's of low viscosity. So whilst it's of low viscosity, it has the capacity to get through that little hole there and drip into the airline and lubricate that. So as long as you're lubricating that air motor, there's no problems. Now you see there's 2 valves here. One valve here is for this particular regulator, and all it is a moisture trap. So the moisture can build up in here, and it has a sight glass here to indicate to me how much moisture may have accumulated on this side of this particular unit. So the valve here, you can vent that or exhaust that valve with air on it if you wish to, or without air on it. Ultimately, it'll come out of there. On this side of it, there is the oil planetary or gallery that holds the oil that I require to lubricate this particular unit. So the air's coming in, going through the regulator, going through the oiler, and going back out the other side. So as it goes through, it pulls the oil from this particular vessel back through and into the system. So this one here has a sight glass on it. Now this is not water or moisture. This one here is actually oil. That particular oil that you'll fill this when you need to replenish it, as it shows on this sight glass. So on the sight glass itself it says maximum full. So the thing to remember is with these is that be very careful of that little O-ring on the edge of that bowl, because if you damage that, they're an odd size. So if you're out on site and you damage that, you may have to wait until a replacement can arrive. Also too, you can see in this, the oil is nice and clean, clear, which is reciprocated in the sight glass itself, so that you can see how much oil is in there and when it needs to be replenished. So always when you put these particular bowls back on, it's important to have a piece of rag and just wipe around the top gently, not to get any contaminants in there, and wipe around the seat too, where it goes in, so that you ensure it's nice and clear and clean. Then a small amount of lubricant around the O-ring and put it back into situ. So it's quite a agricultural thread on these, which assists in getting it back into its housing. And then of course, don't over tighten it. If it was loose, air would leak from there, so you need to make sure that it is home, but don't over tighten it. So with this valve, if you open this valve, that'll vent that and enable all the oil to escape. But so this particular one, don't open that butterfly. This particular one is to vent any excessive moisture that may occur. So say, for example, excessive moisture, you say to yourself, but it's an aftercooler, it's supposed to remove all the moisture. If, for example, I had that valve shut and it wasn't venting on that primary bowl here, it can build up moisture and still send it through the other end. So it's important that you vent this particular moisture accumulator with the valve cracked slightly open before it starts entering the cooler. Now the compressor will make a lot of moisture, particularly if the relative humidity is high or substantial. So there is always the opportunity for the compressor to make moisture. What exacerbates it too is the hose is laying in the sun. This whole unit in its operational function, you'll crack that valve at the bottom, that valve there, and let any excessive moisture be dispensated through the vents on the bottom of those. So it's important I maintain the right amount of air that the compressor has a capacity to deliver to me. Just remember too, if I crack that all the way open and cracked all the way open, I'm simulating another exit of air. So I could be simulating another blast nozzle losing excessive air. And the last thing I need to lose is excessive air if my two compressors are working to their capacity. So you only need to have them weep to let the moisture out. So as far as this unit's functionality is concerned, it does a lot of things. It just sits there and looks at you like that, but ultimately it's an accumulator, cools the air, makes sure the moisture is displaced in such a manner that it doesn't impede the operation of the equipment that I'm trying to utilise. And don't forget that as far as this regulator is concerned, to run this air motor, there is an isolation valve on the back of this. Now with any pressure vessel, there must be a relief valve. On this particular unit, there's a relief valve over the back here. The relief valve, is it compromised by anything, by moisture and so forth? It's serviced every 12 months. So because it's a brass housing, that will be, with no air in this particular unit, that will be removed from the top of the vessel, inspected, cleaned, make sure the seats are correct and so forth, and replaced. We always use thread tape on any fittings that we use here, primarily because we don't want air escaping or leaks. The other thing to remember too, if you don't put thread tape on these and you have moisture escaping here, it's coming through a small hole. So ultimately the thing will get hot. So you leave yourself susceptible to burns and also to impregnation of your skin with that excessive air that may be escaping from those areas. So the safety aspect of these things is paramount importance, not to be overlooked, always to be adhered to. It's written in your JSA, so if it's written there, you adhere to it. So primarily the function of this particular unit is to receive, cool, dispensate air. After you've used this particular unit for 6 to 12 months, if you have a compressor that's in poor repair and making oil, pushing oil up into these particular lines, what you will need to do is there's a hand hole in this particular unit, in that there's bung in the top. All these fittings need to come out, and the tap that's on the bottom of this unit is unscrewed. So what you're doing is you're removing any fittings that are on this particular unit, making sure it's isolated with no air on it. And then we use something like a hot wash unit, so every 12 months, or a lot sooner than that if your compressor's making oil, you will evacuate this particular vessel, pressure vessel, by ways of putting a hot wash in there, and you'll be poking the wand in there and washing this particular unit. You must wear the appropriate PPE. You must wear glasses, you must wear a face shield. I advise you to wear earmuffs because the noise of the nozzle poked around in there. How much pressure would I need? 20,000, 30,000 PSI? No. 1200 PSI of hot water is more than adequate to wash, cleanse the stainless steel mesh that I spoke of in there, and also to wash the walls. Would I need to recover the water that I wash out of there? Yes, because it may be oily. So I make sure that I capture the moisture that's released from the bottom of this pressure vessel because I'm hot washing the thing. Is that the maintenance that's required? Also at that period of time when I wash it out, I check ball valves for their seat concentricity around the ball, the seals, so the taps, the handles, make sure they're nice and tight. Any gaskets that I may remove, because ultimately when you wash this, you will need to take this return line or the feed line, primary feed line into the receiver. You'll need to take that off. Now underneath those flanges there is a clingerite gasket. It's made of clingerite to cope with the temperature of the air if it does exceed any temperature, and also too it's designed to, the clingerite gasket is designed to have a configuration in such a way that it copes with the pressure. So when I remove those flanges and undo those series of bolts to evacuate this particular unit of any oil, water and so forth, I'll check the repair of those clingerite gaskets if they need replacing. Ultimately you'll cut some more, or you'll ring the supplier and say, can I have some more gaskets for this particular unit? So the gaskets in these particular fittings as well, they're checked, to be quite honest with you, every time you undo these units. So every time I undo this hose, I'll check those gaskets for good repair. It's of paramount importance that they are checked daily if they're removed, to ensure that they maintain the full surface, the full extrusion of gasket from the parent metal out to the marrying gasket on the other or alternate fitting. So if you do all of the things that we recommend in relation to taping properly, checking gaskets, whip checks, pins, evacuating any excessive moisture, making sure that it's lubricating, making sure the fins are clear and clean, the fan is spinning, the return air is not hot, all these valves are shut prior to putting air into the machine. If you maintain all those visual aspects of it, if you maintain a visual in relation to the aspects of this particular machine, you'll stay safe, the machine will work to its optimum, and more importantly, the job will get done quickly because you've got a particular machine here that does a specific job. The specific job is to remove moisture from my primary air. If I'm doing that, that maintains the longevity of the subsequent equipment attached to this particular unit. So stay safe, look after the equipment. If you look after it, it'll look after you. And ensure that you do follow any procedure in relation to this particular unit. And thanks for watching.